Hello everyone, my name is Ibrahim Nadeem and welcome to another episode of TECHABOUTS. I've not been uploading for a very long time, and that's because I was very busy with my schoolwork and also my exams, in which I topped with a score of 96%. So I've also completed my topic of self-driving cars, and now I'm back to explore deeper into the world of programming. And now I've started a topic that is more mysterious and entertaining than anything I've ever learned before. And that topic is the concept of blockchain, which will be explained by me to you all. So, before I show you all the code and the applications of blockchain, I'd like to explain you all a little about the topic. So, blockchain is actually certain a certain set of blocks. As you can see here, there are three blocks, and the actual blockchain does not consist of only three blocks. The transaction which is carried out by the blockchain consists of billions or trillions of blocks. And these blocks right here are just for representation. So the first block you can see here is also called as the Genesis block, having its own hash code. As you can see here, 6U9P2, and it does not have a previous hash. It's given here 00 because it is the first block of the transaction and does not have a previous hash code. But when the block carries on and goes to block 2, you can see here that it has its own special encrypted hash code, but the previous hash code has been set to the hash code of the Genesis block, that is the first block. And once the transaction has been carried to the second block, there will be a proof of work, also called as nonce. It will be telling us how much amount has been carried to the second block. And then moving on to the block 3, it will have the same effect, meaning it will have its own new special hash code, as you can see here, 9I4Z1, and its previous hash code being the hash code of the second block. And let's say that block 3 is the final block after billions of the transactions carried out by the blocks. Block 3 is the final block. So, whatever transaction which has been carried out, the amount received to the receiver will be called as uncle reward. I know it's a funny name, but I don't know why. So, once this transaction has been completed, I'd like to show you a more real transaction. So, right here is the transaction of a real person. So, you can see here mined by this person, and the name or the account of the person has been encrypted by any encrypted algorithm to keep the confidentiality of the person. And then the block reward right here is how much ethereum has been transacted, and then the uncle reward is 0 as of now, meaning that the transaction is not completed yet and they have not got the complete amount. And the difficulty and total difficulty shows that how much time it was taken, and then the size means that how much data was required to carry out the transaction. The gas used and the gas limit refers to all the all the ingredients we can say, or all the data required for carrying out this transaction or this process using the blockchain. And then extra data is all the data which was used. Hash is the hash code of the current block at which the blockchain is on. So, as I told you, the transaction is not completed yet, and that is why the hash code is still on the in between the blockchain. And then the parent hash refers to the previous hash, meaning that this is the hash code of the previous block. And then SHA3 uncles refers to the the amount which has been received to them as of now, and the amount has been encrypted by an encrypted algorithm called as SHA-3, and then state root and nonce. I told you already, nonce is the proof of work and the amount received to the current block, which is this block. So now that you know more about blockchain, which is as much as I do, let's show you what I have done with the coding as of now. So right here is import hashlib. This is a library in Python, of course, which helps us have all the encrypting algorithms into one single library. So let's run this file. So I'll open our command prompt, and now I'll activate our blockchain, which is the environment. So now that it's activated, you can see here we're into the environment. Now we'll run the file. So the name of the file is add underscore 238.py. So Python add underscore 238.py. So once we run it, you can see here that it's been printed that the number of hashing algorithms, meaning that the encrypting algorithms in this library are, now these are all the different methods of encryption: SHA-224, SHA-3256, SHA-256. So these are all the encryption algorithms which are present in this hashlib library. So now that you know about the number of hashing algorithms, let's show you how we encrypt these files. So right here we have imported the library, and then we've defined a variable called as message, in which we can write anything. So for example, we'll just write hello world. So once this is done, the output, so we're encoding the message, which is a function of the hashlib library, and then after that we are encrypting in this line result equals to hashlib.sha256. So we're encrypting the variable, which is output, with the language SHA256. Now you could keep it any other language, but this is the one which I found my favorite. And then after that, we print the statement, and then we are just encrypting it. So to show you this, Python will just run this file underscore 2382.py. So if I write any message, so I wrote anything gibberish into the message. Hello. I'll run it again. So it's asking for the message. Enter your message. Once I run it, hello world. And when I press enter, it will encrypt this text. So it's clearly saying here your message in SHA-256 is, and this is the encrypted text. You might find it very similar to this type of text, and this is because there's the same encrypting algorithm. And now you've got to know about how we encrypt the data of the user and the transaction. Let's show you how the transaction works. So this is the transaction and its record. So the sender is Satoshi, recipient is Mike, and amount is 5 ethereum. So these are all example names and amounts. This is not a real transaction. So this is all about the chain, the blockchain, and detecting whether the block is the Genesis block or what. So I'll run this file, Python class underscore 239 dot Python. So as you can see here, it's showing all the data about everything, which is index, timestamp, transaction in which the sender, recipient, and sender and amount, and also the gas fee, which is zero, the previous hash, and then it is stating that there is no previous hash since this is the first block. And then the hash code of the block has also been given right here. So that's how we detect, and the data is also stored in a ledger. And this is all I've learned as of now in my journey of blockchain. So this is it for today. I will keep you all updated on my journey of blockchain. Thank you. I'll see you in the next one.